Hello, everyone. Yeah, I know it. Like we are almost nearing lunchtime, but I promise I won't come between you and your lunch. So I'll try to wrap up quickly. So, hello, everyone. How are you all doing? Okay. So, I'll just start with a brief introduction. I'm Kamlesh. I'm from India. I work as a principal engineer at Razorpay. What do I do beyond code? Like front end to me, like front end is all about you seeing some gratifying things that gives you like a pleasing experience. And for me, it has gone beyond code. Um, and recently, kind of got into home like interior decors and and things. These are like some of the things like me and my wife, we kind of did some things to our parents' house, and these are like just a glimpse of what front end means to me beyond code. All right, so let's come back. Let's talk about the sorcery of building a cross-platform design system architecture. Before I jump into that, how many of you over here use React Native? All right, and how many of you use React Native because you know React and your company or you're like kind of asked to write React Native because in the end it's React, right? Okay. So just a disclaimer, this is like just a journey or an approach that has worked out for us. It might be different for you in like based on different factors. So let's start with the problem statement. So we had a problem statement where we wanted to build a design system which would work cross-platform. And for us, cross-platform was that we had mobile apps which were built using React Native, and our web apps, of course, built using React. So we wanted to tackle a problem where we were working to build our design system, and we wanted a way where we don't have to write or code each and every component twice, and we wanted to make it like just write once, and then we can use it on both the platforms. So we started evaluating different approaches. First approach, this is like the common approach. You say have individual teams which are building for each platform, right? You would have a team which is working for web. You have a team which is working for iOS, for Android, or let's say if you are using like React Native, you would have like teams working on web and React Native. But there are certain pros and cons to it. So first, let's talk about the pros. So expertise of people for each platform, that's like a pro, right? Because web developers know what they are best at, and the native developers, they know what they are best at. And then you say, like you get to use the native capabilities of both the platforms. There are certain things which the native, mobile native is very good at, and there are certain things which the browsers are very good at. So you get both best of both worlds. But there are certain cons to it. The first one was multiple teams for building the same thing. Of course, it could, like if you have like iOS and native Android, you would need different teams. But for us, we had React and React Native, so essentially it didn't make sense. And then redundant code for similar things. Less unification of APIs, like there would be two teams working on two like same component but in disjoint fashion, and they might end up with having two different APIs because let's say there are certain things which work on web but it doesn't work on React Native or vice versa, right? So there was another approach which was use React Native web. Again, it had pros and cons. First, we got the pro, which was write once, you use it and use across web and native. Second, use similar APIs across platforms. There are certain cons that, the cons that were again applicable to our use case, where the React Native devs had to write for web and native both, right? Which means if you are an app developer, you need to now understand the gimmicks of browsers as well. And then it was like native first and then parity with web. None of the above kind of fit our needs. We were looking for something which is that has like same API that works across web and native. And then we wanted to still utilize the power of each of the platforms. Few things which the web is great doing at, we wanted to utilize that, and same for React Native. And then we wanted that our devs, like our app devs, like should be focusing on what they are best at, and same applies for the web devs. So basically our desired nirvana state would be that if a dev had to implement below across platforms, right, which is a layout which works on both the platforms, they should be literally able to just copy paste this thing, paste it in web, like your React code base, it should work, paste it in React Native, it should work without any hassle. That was our desired nirvana state. That's how we started off with. So let's see how did we approach this. So we started with listing down like what all things we need to tackle. Like since we are approaching a different thing altogether, we wanted to start with what are things that we need to account for. The first one was we wanted same API that would work across platforms. Second, we should be able to test these things or the components for both the platforms because we wanted to be ensure that okay, this thing works on web as well as React Native. So we wanted a test setup that would test these things entirely. And then we wanted to even bundle each platform separately along with the TypeScript types. Now, let's see things in action by implementing a typography component, right? We will just, I'll just try to build a typography text component and we'll see how we approached all these things in different phases. So first thing, same API work across platforms. Now, let's say we want to build a simple text component, and this is how a basic text component API would look like, right? You have like some basic props, ID, color, font family, font size, font weight, text decoration, line height, text align, and truncate after lines. That's like the simple and the most basic API, right? Now, in order to implement this, the usual way or like the common approach that everyone takes is like, okay, fine, we'll just take it, make it work in a component. First, we'll try with the web implementation, right? So we are using styled components over here. So we say, okay, fine, style.div, put all the props, and then we kind of return that or we export the text component. Now, next, we'll implement it for React Native as well. So we are again using style components over here as well. But there's something that is going on here. Like let's spot the differences. So on the left side is the web implementation, on the right side is the native implementation. So if you see, the highlighted part is common, right? It's common on both the platforms. Similarly, the export is also common, right? Essentially, literally the same. The only thing that is different is what you are using from the style component or like the native component, because the div doesn't work on React Native, right? There's an exact text implementation that React Native offers you. Now, this is the only thing that differs. Now, let's see, like this is not what we wanted, right? So let's see what we can do to make it better. So first thing, we saw that the styles are common. Let's try to abstract it out, right? So we create a function called getTextStyles, make it accept certain arguments, basically our props, and then let it return all the props based on some styling. Now, we could literally remove this part, right? And we can replace it with the function that we just wrote. So now we have our two big implementations is now refactored to this much, right? So you just call getTextStyles. Now, next step. Now we want to expose something like below. So we abstracted the styles, we refactored our component, but still we are not there, right? So what we wanted was, as a consumer, if you say you want to import text from design system, right? The build, the bundle that you get from design system should internally be able to identify whether it's a web or it's a native component that the consumer is asking for, instead of consumer explicitly mentioning it. But how do we turn this concept into reality? So, file extensions and bundlers. Before we go deep into file extensions and bundlers, I just want to talk about how Metro which is a bundler for React Native, how does it resolve the files, right? So let's say if in your project you say import file name from file name, right? Metro will first try to look at filename.android.ts. Does it exist? Yes, it will resolve it. If it doesn't, it will now search for filename.ios.ts. Similarly, it will go to native and then .ts. Wherever, like this is basically the file resolution priority that Metro takes into account. So what if we steal this idea and make it work on web? So Webpack provides you the Resolve Extensions API, in which you can mention the priority of file resolutions that you want to want Webpack to take into consideration. So what we have added over here is we have added web.ts to the beginning of the array. So we are trying to tell Webpack that, first you should look for if there exists a specific web implementation of this file, resolve it. If not, then you fall back to the actual things, which is .ts, .tsx, .mjs, and so on.
Here's what I found.
Okay. So this is how Webpack would now behave, right? So we say import file name from file name. It will just look at .web.ts. If it finds, it will resolve. If not, it will go to the regular file. So now Metro and Webpack are kind of in line. Now let's go back and rename the files. So we had textweb.tsx, but now we are turning it into extension, which is text.web.tsx, which had the exports for web. And similarly, we have text.native.tsx. Let's see if things are working so far. So let me show you. So we had, I think much better. Okay. So this was the web implementation where we are saying get text styles. This was the text styles that we kind of refactored and made it work. Similarly, we have text native. So if you see the web and native side by side, they look similar, right? Except style.text and style.div. Fine. And then from index, we'll just say, okay, export star from .text, right? We'll just go and see if things work so far. Okay. All right. So things are rendering as expected, fine. But there is a problem. Can you see? It's basically saying cannot find module text or its corresponding type declarations. So what have we done so far? We kind of made Metro understand how our file extensions work. We have made Webpack understand. So our build is working fine, but we have not yet intimated TypeScript of how should TypeScript resolve file-based extensions, right? So what TypeScript is trying to do over here is we are saying index.ts, and when you say /text, TypeScript is trying to find text.tsx, which it is unable to find because we don't have such file. So how can we fix this? What we can do is we can create a file which is this, and then we can say export text from text.web, right? And let's see if this is fine. The reason why I'm doing text.web over here, actually it doesn't matter whether I do text.web or if I do text.native, because so far our API is same, right? The types that we have is literally the same for our text. So whether I re-export text.web or text.native, it doesn't matter. So things still work. Web, native, and our TypeScript compiler is also happy. Great. Let's come back. So basically, we kind of configured bundlers to resolve file extensions, and then we kind of also we told TypeScript how to resolve .web and .native things. So coming back to our checklist, basically we have achieved, or we have like a bare minimum version of same API that would work across platform. So what we are going to do next is let's move to testing, right? We want to test things on both the platforms. Now, we are using React testing library. So we'll try to configure Jest to again understand the web extension, like the extensions that we are trying to work with, right? So what we'll do is we are trying to, this is basically a Jest config for web. We're trying to tell Jest that, you should ignore all the .native, .test patterns, and you should only include .web patterns. So when Jest is trying to run the test and it comes across a file extension which just says import text from text, for web, it will just ignore all the native parts, and it knows that it has to look into .web extensions. Similarly, we'll do for native. It's like a inversion of what we did for web. So over here, we are ignoring .web, but we are including .native. So now we have two Jest configs. So let's write some test. What we have done over here is we have just imported our text component that we just implemented. We have just returning the component so that we can test it. We'll create a file called text.web.test.tsx. Again, it has extension with it. And then we are saying, like, we are just importing the web utilities from React testing library, and we are saying, okay, fine, render it, and then we just do a snapshot. Similarly, we do it for text.native.test.tsx, right? Again, the internal underlying API is different for React testing library and testing library native. So we are just reusing the component that we want to test, and we are just wrapping it around the APIs that it needs for native. The reason is that we want to be sure to render these components on these platforms so that we can be 100% sure that it won't break because of our abstractions. So let's see things in action. So over here, we'll go here. Let's see the Jest. So this was the Jest config, a lot of things. And then similarly, we have native. So these are two things. What I'll do over here is I'm going to run React, which is basically is going to test. And then I'll also run React Native. All right, so tests are working. So far, so good. Let's see if we have found the snapshots to be generated. All right, so we have text.native, we have text.web. So far, so good. Fine. So at least we are sure that, okay, things won't break on web versus native. So coming back to checklist. So we have achieved our same API kind of a model. We have testing setup that would test our components on both the platforms. Now, let's move to bundling, right? But the question comes over here is like, what shall we use to bundle our design system for both web and React Native? Any guesses? All right. We'll use rollup. So in order to use rollup, we'll first try to configure our Babel config, right? Because we need different presets and plugins for React Native and different presets and plugins for web. So we'll start with React Native. We'll just say, okay, fine, this is our React Native. Configs is an object which has React Native, which has presets and plugins defined for React Native. And then we have a key called React, which will have presets and plugins for web. And then what we do is we kind of pass an environment variable, which is framework. And based on that, our Babel config will return the respective config based on the build that is being run. Hold on, I'll just try to explain later on. Next, after Babel, we want to configure rollup, right? So now, again, coming back to rollup, we'll mention all the web and native extensions. So we'll say, fine, read the environment variable that is being passed, which will tell what platform we are bundling for. And then we'll pass the web extensions that rollup has to start looking into, and then we'll also, of course, give it the entry file. Similarly, we'll do it for React Native. And then next step is we add 3 scripts to our package.json, a build which will basically run 2 build scripts in parallel. The first one is build React, which will set framework to React. And the second is React Native, which will set the framework environment to React Native. Let's see how all this works. Like, let me try to help you visualize. So when we run build, the first script, let's say when build React runs, it will set the framework environment variables value to React. That will go on to Babel config. If you remember, we just wrote this config. Over there, it will just read the framework variable. It will identify, okay, it's React. It will try to export configs.react. Next, it will go to rollup. Rollup will also again read this environment variable, which is React. It will return the config that will help us to build for web. And finally, we'll have our output, which is build/component/index.web.tss. Just focus on the extension that we are outputting. Similarly, we'll repeat this for React Native. When, like the first step, we'll just set framework React Native. It will go to Babel config, spit out the config for React Native, same for rollup, and then we'll have index.web and index.native. So we have 2 bundles. One is web, one is native for our consumers. Let's see if this setup actually works with rollup. So so there's no build folder right now. I'll just try to build it. Yeah, build. Building. All right. So we have our build output. Everything is over here. So we have native. Just try to remove this for now. Yeah. So we have .native.ts and then we have .web.js. Like both the JavaScript bundles, we have it in output. So far, so good. But we forgot about types. What we have done so far is we have bundled our code to, like, it's basically a JavaScript bundle. What about types? Like, the problem is our types are co-located side by side to our components, but we bundled our source code. It was like we had a bunch of components, it got bundled into one code. But what about types? So the solution is we also need to bundle our types so that it matches our structure as our library, and that's how all our code editors and everyone would be able to provide you all the IntelliSense. But how are we going to do that? Roll up to the rescue again. Remember this old config that we just configured, right? What we'll do is we're going to use rollup plugin DTS. That is basically the plugin that will help us bundle our types. And then we kind of add this as a config that, okay, you just define the entry point the way we do it for our source code. And what it will give you is it will just go into the whole, it will build the tree and then combine everything into one definitions file, and it will just spit out. And this is what we would want. This is our desired output. So let's see. We'll go to rollup config. And so, yeah. So this is where we are trying to tell rollup that, there is a config file that you need to read and then give it an entry point, and that's how it will start bundling our types. Let's try to bundle it again. And again, we are trying to do it directly, like we don't have to write explicit command. since it's part of our roller config. The moment we run build, again it's going to build everything based on the config. And this time, okay. So it kind of built, like it combined or created a bundle for our types. And if you could see, we have everything over here, text, text prop, everything. So we have web.js, we have native.js, and then we have our type definitions. So far, so good. And our output is also working. Fine, let's come back. One thing that I want to highlight over here is that we need only one types bundle, because as I had mentioned, our API is common for both web and native, and that's how we have been proceeding. Like that's basically our first consideration, right? That okay, we need a common API. So our checklist, same API, work across platforms, testing setup to test for both the platforms, bundle each platforms along with the TypeScript types. But wait, what about accessibility, right? So let's see how we can tackle accessibility. So these are like some native and web accessibility props. On React Native, let's say you call accessibility role description, but on web it's called area role description. Same for other properties. So again, we have a problem. Taking the same approach that we did for our components, first we'll create a map for common key names for both web and native. So for example, we'll create a key called label, which will map to accessibility label for native, and it will map to area label for web. And then as a next step, we'll put a function on top of it, which is make accessible. You pass it all your accessibility props. It will do a lookup and return you the key, return you the respective prop for that particular platform. Now let's see it in action. So taking the same text component that we just implemented, we'll import accessible function, accept all the accessibility props from the consumer. Before we render the component, we'll call this function, which will convert or do a lookup to our map and render the respective accessibility prop for the platform that we are trying to build. And then when I come to usage, as a consumer, I'll just say role heading. Now it will just render accessibility role on native and area role on web. Whew, finally, the demo worked, right? But there are some common questions. There would be a lot of questions running across your minds. The first thing, what about bundle size, right? We all like to speak about performance, so how can I skip bundle size? If you remember, we bundle each platform separately with rollup. So there's no footprint of native things going into web and vice versa. So we have two bundles. They both are completely isolated. The way, like as a design system developer, you are writing the code that would run across platform, but we have kind of made our bundlers more smart so that it doesn't like mess up things in either of their platforms. The next question, we still have .native and .web. Isn't that an overhead? Well, I would say not really, because we have abstracted most of the things that we wanted to. Another advantage that you get with having these two files, separate files, is that you could actually add more fine-tuned checks if you want to. For example, if you want to add some platform-dependent restrictions, like if you have used style components, you kind of use you might have used as prop, right? Which helps you define, okay, what kind of component you want to render it. But as doesn't works on React Native with style components, right? So with that, you could add as a restriction that as a consumer, if you're trying to say as, it will just throw an error that, hey, you can't use it. And the two platform files are required only when you're defining your core or your base level components. Now, what do I mean? So we built text, which was like the most low level component that you would build. Now imagine that if you want to build heading, right, which is an extension of your text component, or it would be built on top of text with certain properties being modified and different heading specifiers, right? We would just need one heading.tsx. That's it. Over here, now you don't need two files. You would just say import text. Now, text is the one that has to be natively rendered for either of the platforms. But when you're building on top of it, you would just need one file. That's it. You don't need to go around the mess of, okay, I need to create heading.native, heading.web, nothing. You just define heading, you import text. Text is implemented for both the platforms. Your bundlers would identify how it want, like which one to refer for what platform. Now, the next question is, how do we handle platform dependent properties? So we can mark them as optional on TypeScript types, right? For example, the as prop is only available for web, and you can mark it as optional. And similarly, the number of lines is for React Native only. And this is how, like, if you have used React Native, there are certain props which are applicable on iOS and certain props which are available only on Android. And that's how the best way is, like, you could define that, okay, this is optional, but it would just work for Android. And if you need more control, or if you want to have more fine-tuned things, that, okay, even if someone want to do some, like, they want to create some mess, they would try to do it. So what you could do is, you could add some more fine-tuned checks directly in your code. That, okay, hey, we said it's not available for native, but still you are trying to do. I'll break your code. These kind of fragmentation, hopefully they will just go away. There's just an open RFC from Nicholas, who's the author of React Native Web. There are like a lot of bunch of things which are different on both the platforms. The moment we try to reduce all this segmentation, a lot of code that we just wrote might just go away. The next thing is, how do we handle platform dependent types? Like, we discussed platform dependent properties, but how do we handle the platform dependent types? Now, what do I mean? So this is basically our motion tokens. Imagine that we have defined our animations. On web, you would use cubic Bezier. On React Native, we are using React Native reanimated, right? Now, the type of the motion on web is a string, which is like a function, a cubic Bezier function. But on React Native, it's basically a easing function factory. Like, it's of that type. So we can use union types over here, that it could be either this or that. But now with TypeScript 4.7 and above, you could also try to make your TypeScript understand your module suffixes. So you can define that, okay, these kind of, like, when you're working on web, you have to look for the types which are in .web file, and if you're working on on native, you could look for types into .native file. That's basically 4.7 and above. Does it scale, or is it just a concept? So we use this kind of architecture for, like, it's been more than a year. Most of the products have been running on this kind of this setup. We have been working fine so far. So I think, yeah, it works. So let's do a quick recap of what all I just spoke. We started with a single API to rule them all. So, like, why should it be different? That, okay, if I'm defining a text component on web and native, it shouldn't be different, right? Because the properties of the API should be same, because it's, again, being built for a single brand. We utilize the power of file extensions, that is .web and .native. We abstracted all the common things which are platform independent. Like, for example, our style function, we kind of put it in get text styles in a different file, and then we are just calling that function in both the platform dependent files. Keep the platform specific logic in .web and .native. This kind of helps you to put more granular checks into that particular platform. For example, we saw the as prop that shouldn't be used on native. So with that, we can put the platform specific checks. And then we kind of configured all our tools, Metro, Webpack, ESLint, TypeScript, Jest, etc. So that everyone should know how to resolve all these kind of files. And then we bundled each platform individually using Rollup. And then finally, we generated the single types bundle. So the way we bundle our code, we also bundled our types. And that's it. So we kind of just made our bundlers smart, our tools smart, Nothing magic. Everything is like just utilizing or leveraging the power of our bundles. So you can just go check out this entire code base on the demo that I've created, or you can just head to Razorpay/Blade, which is our design system, open source. But this has the whole setup in and out with a lot of other components and a lot of different checks. So that's it. Thank you.